and welcome again to AWS APAC Webinar Week. And welcome to this webinar on common workloads in the AWS Cloud. As Fiona said, my name is Chris Sampart-Sumian, and I'm a technology evangelist at AWS based here in Singapore. Today I'm going to talk about some of the practicalities of running common workloads on AWS. We'll cover running a website, backing up data, using AWS Cloud for disaster recovery, and some others. I'm also going to talk about why, before we go into that though, I will talk about why customers choose the AWS Cloud and what are the benefits of running those common workloads, such as their website or backup, on the cloud rather than on-premise or old-world co-located hosting facilities. And before I dive into that common workloads, for those of you who are new to AWS, I will highlight some of the benefits of running such workloads in the cloud and do a whistle-stop platform tour of AWS services. So we'll have a quick glance at over 40 services in all, and then we'll drill down on maybe 8 of those which we're going to use for the common workloads. I'll call out the ones that we're going to be running our common workloads on. Okay, so why are companies choosing the AWS Cloud? It's the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. So the two important things there is that it's delivered by the internet and it's pay-as-you-go pricing. In the case of AWS, that's commonly hourly pricing. So instead of buying and owning and maintaining your own data centers and servers, organizations can acquire technology such as compute, power, storage, databases, and other services on an as-needed basis. It's similar to how you flip a switch and turn on the lights and the power company sends electricity. Now you can switch on IT resources and equally just switch them off again. And as I say, in the case of AWS, that's on an hourly basis. So it changes the way we think about computers. No longer is it a 3-year cycle of procurement and depreciation and decommission. At the end of that 3-year, it's literally by the hour. So you can use the resources for the hours that you need them and then turn them off again. That really changes the way we manage computing. So AWS manages and maintains that technology infrastructure in a secure environment, and businesses can access those resources via the internet. And they can develop their own applications on top of that. Capacity can grow and shrink instantly, and business only pay for what they use. That's the other key differentiator. You only pay for those hours that you use, and the moment you turn it all off, you no longer pay. So why are companies moving to the AWS Cloud in such large numbers? So we'll have a quick look at 5 reasons why they're moving to the AWS Cloud. So we found that the number one reason that businesses move to the AWS Cloud now is agility. It's let customers quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. This means they can very quickly develop and roll out new applications, and it means teams can experiment and innovate more quickly and frequently. If an experiment fails, you can always deprovision, and then you no longer pay, and there's no risk, and there's no overhead, and no burden. So that ability to just start your project as you have the idea with very, very low risk attached to it. If it doesn't work out, you just shut it all off and stop paying for it. That's a great reason to move to the cloud, and one of the reasons we're seeing businesses move in such large numbers to the cloud so quickly. So the second reason, of course, that I'm going to talk about today is that AWS brings considerable cost savings. So AWS allows customers to trade their capital expense, where you used to have to spend, do your PO and your bill of materials and do your big purchase order for a large amount of computing capacity, and you can completely trade that capital expenditure for a variable expense. And typically that variable expense is lower than what you would have been paying anyway. So then you pay for the IT as you consume it rather than paying for it up front. And the variable expense is much lower, as I say. If, for example, Dow Jones has estimated that migrating its data centers to AWS will contribute to a global saving of $100 million in infrastructure costs over several years, or the Commonwealth Bank of Australia, which has halved its storage costs and is estimating it will save hundreds of millions of dollars. So that's a pretty compelling reason to move to the cloud in itself. The third reason I'm going to talk about today is that the elasticity of the AWS Cloud. You no longer need to forecast demand and buy up front. You get the ability to scale up to meet the needs of a spiky workload, but then give back the capacity when the spike is over. As I mentioned earlier, that's on a granularity of an hourly basis. So whether you're dealing with annual spikes like December retail boom, monthly or quarterly spikes, or as I say, even hourly spikes, that unpredictability can be taken care of by the elasticity of the AWS Cloud. The fourth reason I want to talk about today is the breadth of services and functionality that exists on AWS. We have more than any other platform, and we continue to add new capabilities and new services at an accelerating pace. In 2012, we launched what we considered 159 significant services and features. In 2013, that number was 280. And we closed 2014 having announced 516 new services and features. And this year, we've continued to improve the platform with regular new announcements. Customers benefit from this continual evolution, innovation, and iteration because they get the newest, latest features or enhancements instantly. No need to upgrade, deploy, or to migrate, or wait for your platform to be decommissioned, or new license, you just take advantage of the new services as they become available. Whether that's new CPU instance types in new instance types, you can literally shut down your instance and then bring it up as a new instance type and take advantage of that new performance straight away. So the fifth reason I want to talk about is the ability to go global in minutes. AWS has the concept of regions. It's a physical location around the world where we have a cluster of data centers. We call each group of logical data centers an availability zone. So using AWS, customers can leverage 11 regions and 28 availability zones around the world. And we also have 55 edge locations around the world, and we don't plan to stop there. We think we're going to continue to build out regions, availability zones, and edge locations. So there's a region here in Singapore, and we have regions in Sydney, in Tokyo, and we have a region in preview in Beijing as well. And they're the same. When you're deploying into Singapore, you can literally, it's the same interface, the same APIs, the same console if you want to then deploy into Europe or into America or Sydney, Australia. So you can literally take your deployment and go global in minutes. Okay, that was just a brief intro on the 5 reasons why cloud computing is important. And before I get onto those common workloads, I'll give you an overview of the 40 services that range from compute, storage, database, analytics, applications, and deployment services. So we'll take a look at those, and I'll try and call out the ones that we're going to be using in our common workloads. And this should give those of you who are new to AWS an idea about the breadth of services that are available. So, first, as I mentioned, the global infrastructure is 11 regions. Here in Singapore there's a region, and there's several across Asia Pacific. Each region has at least 2 availability zones, so customers are able to deploy their application across these distinct availability zones, which are on different floodplains, different power supplies, and it gives very high availability to applications that are architected across 2 availability zones. And I mentioned 55 edge locations, and there's anything from Route 53 DNS, which we'll be looking at later on as part of our web hosting common workload, and also content delivery network, which is another one that we mentioned. It's to accelerate the delivery of your website using our CloudFront content delivery network. So of course customers don't have to build anything. These regions, availability zone, and edge locations are provided by AWS. So on top of that global infrastructure, we have the networking components. So there's VPC, which is Virtual Private Cloud. There's Direct Connect, which we'll touch on later when we talk about our backup and recovery to the AWS Cloud. So Direct Connect is like a private circuit directly into the AWS Cloud. And coupled with VPC, although I said, just to determine a differentiation here, while I said cloud is delivered over the internet, it doesn't mean you have to have an internet-facing workload. You can have a virtual private cloud that has no internet gateway and has a private direct connect from your facility or your office into the virtual private cloud, and no internet-facing component whatsoever. So don't think that it's like internet-facing, that means the whole world can access it. You can have a very private cloud as well. And then another part of the services in networking is Route 53. That's available as a DNS service from all of our 55 edge locations, and I'll just mention on there, because we will look at DNS later on as well, or Route 53 later on as well. That actually has an SLA of 100%, because it's our only service that has a 100% SLA because it's distributed across the globe, and DNS by nature lends to that distributed deployment. Okay, so as well as the network services, there's the core compute services. This is like, the basics of really any cloud. And EC2, the first one there, it's actually Elastic Compute Cloud. So it could have been called ECC, but it was called EC2 rather than ECC, because that could have got confusing. That is our, all our different instance types, many instance types to choose from, and storage that you can attach to them, and lots of features and services that attach onto EC2. We will create an EC2 instance in this webinar today. So we'll take a look at that in our common workloads. ECS is one of our newer services. That's a EC2 container service, which is it's managed Docker. So if you've used Docker, you can actually, rather than have to build a Docker server on an EC2 instance, ECS will manage the Docker service for you, and you just deploy your Docker images. Lambda, again, is another new compute service. This is basically serverless computing. So if you write your code in Node.js, so Lambda supports Node.js originally, you no longer need to build a server to deploy your code to. You can deploy your code directly to Lambda, and it will run as and when it's called. And that one isn't paid hourly, it's paid on CPU cycles. So you can do 10,000 iterations of your code for a few cents. Elastic Load Balancer, we won't look at it today, but it's commonly used as a very for load balancing across multiple EC2 instances. It comes as part of the EC2 setup, and auto-scaling with it. We will talk a little bit about auto-scaling, and that's the ability to flexibly grow your infrastructure as the demand requires. So if you remember my slide a few screens ago, we talked about the elasticity that the cloud brings. We provide auto-scaling as part of load balancing and compute instances to grow your environment as needed. Okay, we'll move on quickly because we don't want to spend too long here. There's storage. Elastic Block Store, which is block storage presentation to instances. Now S3, this is simple storage service, which is it's an internet-enabled storage platform. We will be using this for common workload. In fact, most of our common workloads use S3. So I'll call it out there. It's one of the fundamental building blocks of Amazon Web Services. And along with S3 Glacier, we'll also mention, which is like a nearline storage version of S3. It's for stuff that you need to keep for a long time in a reliable manner, but you don't need to access that often. A bit like a Glacier. They hang around, they don't go away, and they kind of move a little bit slowly. So it's not for online retrieval. It's when several hours is the suitable amount of time to retrieve the data. And of course, the price to store stuff in Glacier is reduced compared to that of S3. CloudFront, I mentioned, runs on 55 edge locations. That's our content delivery network. We will probably set up a CloudFormation distribution today. A CloudFront distribution today, and this is how you can accelerate your website. Very common use case in AWS, and we have CloudFront edge locations in Hong Kong, in Philippines, in Singapore, across India, and typically where our regions are as well. Okay, moving on. So as I mentioned, network, compute, storage, database, another whole tier of services from AWS. I won't spend too long on this, but RDS stands for Relational Database Service. So typically you used to build a MySQL, a Postgres, an Oracle, or a Microsoft SQL Server database instance. But rather than have to build that now and configure it, you can just take a relational database service which run and managed by AWS. And it's distributed across two availability zones, or can be distributed across two availability zones, so you get the very high availability of this dual availability zone configuration. Very effective, and those databases that I mentioned, that was Postgres, MySQL, Oracle, and Microsoft SQL Server, are all supported by RDS. DynamoDB is our NoSQL key value store. So some workloads don't need the power of a relational database, they just need to store data. DynamoDB, like RDS, is fully managed, reliable, distributed across availability zones. And the other thing that's really key about DynamoDB, you can you say how many transactions you want per second, and you can get a guaranteed single-digit millisecond response from the NoSQL key value store. So a guaranteed single millisecond response, that means less than 10 milliseconds, of course. It's typically 2 or 3, but it's always going to be less than 10. And that's really great for building internet-scale applications. So again, it is a common use case, but we won't talk about Dynamo further today. And Elasticache is managed Memcached or Redis. That's for accelerating databases. We won't spend too long on that. We have a whole series of tools for analytics. Redshift is our petabyte scale data warehouse. EMR stands for Elastic Map Reduce. That's a managed Hadoop cluster. Kinesis is real-time analysis of data, and it interfaces to EMR and to S3 and to different components in AWS. Data pipeline helps you move data between various compute and storage services at specified intervals. We also have enterprise applications. So there's Workspaces, which is for a VDI, that's like a virtual desktop infrastructure. So you can run Windows instances in the AWS Cloud and have them sent back over RDP, either to thin clients or to anything running RDP. We have Workmails. They're a pretty new service. I think that was announced this year. We can manage your mailboxes with the reliability that is provided by the AWS Cloud. WorkDocs is collaboration and sharing. Moving on to the higher level services. So far there, before we got into enterprise applications, that was the basic underlying fundamental blocks of AWS. But as you can see, the screen's only half full. That's because over the time that AWS has been around, we've been continually iterating and bringing out new services. So the higher level ones are these application services like Simple Queue Service. If you've ever set up a message queue, Simple Queue Service is a fully managed queue service. Simple Workflow Service. Simple Email Service, just so that if you don't have to set up your own mail transfer agent and do all the good stuff you need to do with the big mail bodies to make sure that your messages get delivered, you can just literally send to the SES, Simple Email Service. Elastic Transcoder as a service. You create an in folder and an out folder, and you set up a pipeline on Elastic Transcode. You drop a video in, and it comes out the other side in whatever you set the profile as. And SNS is Simple Notification Service. We have a whole mobile SDK which offers push notifications to all the different platforms, analytics, identity sync between devices. So if you've got a user on an iPad, an Android phone, and on a PC or Mac, you can sync the session state across all of those devices with Cognito. And that's available in the mobile SDK. I'll keep moving so we can get onto our common workloads. Then these higher level deployment and management services. So as I say, the platform's really matured now. The Elastic Beanstalk is actually puts together a bunch of the services underneath, like EC2 and load balancing, ELB load balancing and auto scaling, and even RDS, and builds a whole web hosting platform for you. So we'll probably talk about that a little later after we've talked about hosting a static website. Deployment and management, there's OpsWorks, there's CloudFormation, that's template-driven infrastructure. Code Deploy, Code Pipeline, and Code Commit were all announced in November last year, and this is to facilitate you managing your code, deploying it to your instances, keeping a safe repository of your code in the case of Code Commit. And finally, of course, our top priority is security. We provide a whole bunch of tools to ensure, we provide a secure physical environment and tools to make sure that you can build secure, robust applications. So, for example, right in the middle there, identity access management. You can have fine-grained control about who and what applications have access to what bits of data. CloudWatch is monitoring and metrics and alarms, all that. CloudWatch comes by default with any instance you set up. So CloudWatch actually would have been another great common workload story. So it's free. It comes with EC2. AWS Config and CloudTrail. The other one I'll call out there is KMS. That's the Key Management Server. Again, another one announced in November 2014. So we provide encryption and security on lots of our services, and we can manage the keys, or you can run a KMS server in AWS, so you manage the keys from the KMS service. So on top of that, so on top of that, all of those services are accessible via a web console, which we will see later on. They're all accessible via a command line, which we will see later on as well. One second. And as well as the web console and the command line, we have SDKs for Node.js, Ruby, Java, JavaScript, Python, Microsoft.NET, PHP, and the mobile SDK, which I mentioned earlier. So you can interface to all of these services via software developer kits, and simultaneously via the web console and the command line. So very, very flexible in how you interact with AWS. And of course, we have different support services, business support and enterprise support, and forums as well for discussion. Okay, your applications. So what are the common applications that people are running on the AWS Cloud? They're built typically on those services, so as I say, we'll talk about 8 of them. The first one that we're going to talk about is day one. Our first common is running your website on AWS. This can be as simple as a single EC2 instance running Apache web server and using Route 53 for DNS. Usually you'd set up more than one instance in more than one availability zone, but to show you how quickly you can set up an internet-facing web server in Amazon EC2, I am going to do just that. So If you haven't seen it before, this is the AWS console. And I want to go to, that's how easy you can change region. I just changed from Tokyo to Singapore. And as you see, it's essentially the same console. I'm going to set up one EC2 instance today. So I won't go into any great detail, but there we go. I've got 0 running instances. I'll literally go launch instance. If you're a user of AWS, you will have seen this, but if this is your first time, and just get a chance to see how quickly it is. I'm going to choose Amazon Linux, but you can see there's Red Hat, Ubuntu, Microsoft Windows, lots of different operating systems available there. Then we have all our instance types, anything from micro with 1 vCPU and 1 gig of memory, through to small, medium, M for memory optimized, so you see 1 CPU but 3.75 gigs of RAM, to M32 extra large, that's 30 gigs of RAM and 8 vCPUs. You continue on there, C4, that's compute optimized, so you're more likely to get more compute capacity rather than memory, so 2, 4, 8, 16 or 36 vCPUs. Okay, so there's lots of instances to choose from, but for this example I'm going to choose a general purpose T2 micro. So configure instance. I won't go through all the details because we're just going to show how easy it is, but you can choose what network and what VPC, and you'll see that most of the defaults will be okay. We can add storage volumes. I'm just going to go with the single 8 gig root volume in this case. Tag, and then we'll call this webinar week. You can give it a name and you can set up your own tags. This is the one I wanted us to see. So common workload on the cloud is security groups. It's a fundamental part of anything you do in AWS. Everything exists inside of the security group. So I'm going to call this security group SSH web. That means we're going to be able to access via SSH and web. So currently there's one rule in the security group that allows SSH on port 22 from anywhere. But of course if it's going to be a web server, you'd need to also allow HTTP. That's port 80, and I'm going to say from anywhere, so that's our security group. So we get a warning here saying your instance security group is open to the world. Well, of course, for the web server, that's pretty common. You want it to be open to the world. And in the case of SSH, recommended is if you can not make it open to the world and lock it down to your office IP, for example. We're going to go ahead and launch that. The other thing you need to know in AWS is to access these hosts, you use a key pair. So you don't just use username and password, and I have a key set up already, so I'm going to use my ID RSA Singapore, and I'm ticking that box to acknowledge that without that key you can't access the host. They're just simply warning you that if you go set up a host that you haven't got the key for, then you're going to start paying for something you can't really use. There is very common use cases for that. We talk about making infrastructure that you don't need to log in because it just automatically replaces itself, but it gives us that warning anyway. So if you haven't used AWS before and you haven't set up an EC2 instance, that's how easy it is to get started. I mean, that was probably 3 minutes, but I could have done it in 1. There we go. We can see our instance coming up. So if I grab the public DNS name, I'm going to allow that instance to come up. I could have done a bit more talking there. Right, so I have my key set up automatically. Okay, it's not quite up yet. It's almost there. Now there we go, running. So still just starting up the services, so the instance has come up. Almost there. I'm going to move a bit quicker. If that doesn't go now, oh, there we go. So it's come up. So you can tell it's a new instance because if I type uptime, uptime is 0 minutes. That's how fast it is to launch an instance. So to set up a web server, I would go sudo yum install httpd. Do I want to install Apache? Yes. And then I'd go sudo service start httpd. Oops. Sudo service httpd start even. If I typed it better, it would help. So that's how fast it is to install Apache. The repositories come, get it started. In my buffer, I had that DNS name. And there we go, there's my Amazon Linux test page. If we go cd var, I think www.html, index.html, hello webinar week. Always forget to do sudo on that. Hello webinar week. There we go, and that's how quick it is to get a web server up and going. Okay, back to the slides. So if that's the first time you've seen EC2, you can see how easy it is. Okay, so however, running a single instance isn't the most robust way to run a website. So I'm going to show you an even easier way than that, and even though that was pretty easy, but one that's much more reliable and much more durable. First, let me introduce Amazon's Simple Storage Service. That's S3. It has a durability of 11 nines. I'm not going to try and read them all out, but that means if you store 10,000 objects with us, on average we may lose one of them every 10 million years or so. That's highly durable. That means it's taking advantages of the multiple availability zones and multiple copies of the data. You don't have to worry about any of that. You just put objects in S3, we take care of the durability. It's also low cost. It starts at 3 cents per gig in the Singapore region, and it decreases as volumes go up. It's already architected over multiple availability zones, so you benefit from a very high service level agreement without doing anything special. Just by using S3, you get that SLA, and it's 99.99% of availability, unlike the durability, which is like we don't lose stuff, except if it's one object every 10 million years. And also you've got the option for encrypting your data both at rest and in transit. At rest with AES 256-bit encryption, and at transit using industry standard HTTPS. So naturally it's scalable. It's an object store. So one of the things that this means is that you don't need to worry about file systems at all. You create what we call a bucket or an S3 bucket. And you start placing objects in an S3 bucket. You place one object, you pay for the space used by one object. You then seamlessly scale upward, and for example, you might then put another 100 objects or 10,000 objects in, and you only pay for what you use. That's really convenient. It's internet storage for the internet age. So that's pretty convenient. And there's a few other features with it. We're going to talk about S3 quite a bit because it's very useful for many things. However, I do have a tiny bit of trivia related to S3, and it was related to this weekend. It was someone's birthday. I don't know if anyone knows whose birthday it was this weekend, but that someone was Amazon S3. So it was the 14th of March 2006 that Amazon announced the launch of Amazon Web Services, and this was the very first service that was made available on AWS, and it was Simple Storage Service. So it's the oldest service, and it turned 9 on Saturday just gone. And I managed to find this slightly blurry press release of when AWS was launched on the, you see there, if you look at the date, 14th of March 2006. So yeah, 9 years old this Saturday. So the next example that I want to give the use case for S3, so not only is it durable and scalable and all of those good things, you can also use it as a web server, which is pretty convenient. Okay, so using S3 to host your website. I'm going to go for another demo here. So let's switch back to the console. That was my website from earlier. All the services were on this screen here, but I've kind of conveniently put a few of the ones in my top bar there which I want to get access to. So I'll show you how easy it is to create an S3 bucket. So you just go bucket, region, Singapore. I'm going to go jakarta.com. There's a reason I'm choosing that name, which we'll see in a bit. It's because I have that DNS zone registered in DNS. And then I'm going to create another bucket, and I'm going to call it www.jakarta.com. Just happens to be a zone that I registered in Route 53. The reason I've got jakarta.com and www.jakarta.com, because a common use case for a website is that you want both of those to work. You want people to go to the www name, but you also want to go to what is sometimes referred to as the naked domain. So that's the, without the www in front of it. Okay, so let's have a quick glance at my bucket. It's empty. Right, so if I go here and I go CD sites, common workloads, I've got two files here, an index page and a webinar week graphic. So if I go AWS S3, there we go, AWS S3 sync dot, which is my current location, to my newly created bucket. There we go. I've uploaded 2 files. So now you've seen the web console. You've also seen the command line. So something that I had done in the background before the webinar, I had set up my secret identity access keys. So it means to upload to jakartacutter.com S3 bucket, I did need to provide credentials, and they were transparently provided in the background, which I'd previously set up. So just so you know, if you want to use the command line, that's the first thing you do. Pretty easy to do, but I thought I'd mention it. Okay, so I've uploaded some files. The next thing you need to do to the bucket is add a policy. So as I say, I needed to authenticate, but we want this to be public-facing web server. So I go add a bucket policy. So happens that if I go cd tips cat s3 policy, I have the policy that I want stored there. There's a great how-to on how to do this, and it gives you that policy. So I'm allowing public access to all objects. I'm allowing the action of S3 get object to my resource jakartacutter.com. So I save that new policy, and I save it in permissions. So that's great. And then I also go, right, static web hosting. Here's the good bit. Enable website hosting. That's how easy it is to use S3 with all that good durability and availability. We're going to go index.html, and I'm going to save that. Okay, so endpoint. I'm going to go open that in a new browser. Oh, I didn't save my graphic properly. View. I won't look at it now, but that's essentially my page. So that was. Let's see if I can fix that graphic. And is it called Webinar Week? Yep. We fixed it. So there was a link to the image in the graphic. But you can see there that I've put that on S3. I've edited it locally. I've used the command line to sync it up to S3, and I've made it a public-facing website. Highly available, highly durable, highly scalable. Really convenient. Couldn't be easier. Right. Our S3 bucket has been set up to serve the index page. Let's pop back to the slides and see where we're up to. Okay, so the next step is I was going to introduce another service. Again, a common workload is you will want both your own DNS name and www.DNS name. So we're going to have a quick look at Route 53 to do that. So this the diagram shows example.com and www.example.com. In our case, it was Jakarta Qatar. So we are going to have a quick go with Route 53. So let's go up there. Okay, we have one hosted zone, if you remember. That was why I chose that particular domain name for my bucket name. We're going to create a record set. So we're going to leave it blank, so no name, and we're going to do something interesting here. We're going to say an alias, and the target, hopefully I'm going to see my S3 bucket. Great, I do, Jakarta Qatar. Routing policy, we're going to say simple, but there's lots of great features that you can do in Route 53. So we're going to say create. That's wonderful. And we'll create one more record, and this one is going to be www.jakartacutter. This is also going to be an alias, but this time it's going to be an alias to our what we called our naked domain. So if anyone's familiar with DNS, jakartacutter.com is the A record. Something interesting about an A record is that it normally must be an IP and not a DNS name. But using Route 53, you're able to sort of point it directly at the S3 bucket, because you'll never normally get the IP of an S3 bucket, you'll only get a DNS endpoint. So worth bearing in mind, if you're going to host your website on S3, static S3 as we've just done here, if you want the website to work without www in front of it, i.e. a naked domain, you need to use Route 53 for your DNS. So let's quickly create that record set as well. And let's go, let's see if it's propagated, jakartacutter.com. Okay, it forwarded me. Okay, all right, I won't go into why, but is my zone, when zone go correctly? Jakartacutter.com. Okay. All right. Let's move on back to our slides. Using Route 53 as your name server. So that's how you set up Route 53 to be your name server. So who is using, say, S3 for their website hosting? So Spotify started in 2006 in Sweden. Spotify now streams to a whopping 40 million plus active users. They've got 30 million songs available, and the important thing is here, they've got 20,000 songs added every day. So that's quite a lot of storage needs that they have there. So they're iterating fast, they're innovating fast, they've got a growing user base and an appetite for storage that is growing faster still. So, you know, perfectly suited to cloud for those kind of things. So why did they choose AWS? Why did Spotify choose AWS? So by not only are they able to iterate much faster, removing restrictions of in-house solutions, they're also able to choose a storage solution that meets all of yesterday's, today's, and tomorrow's musical hits. And it grows as their capacity grows. So they use S3 for all those 20. So as well as the 20,000 songs every day, you know, they all go into S3, and they only pay for what they're using. So not only that, I'll also add about Spotify. They're using CloudFront to deliver the client application. So if you've ever used Spotify, you have to download an application to your browser or to your mobile phone, and they use CloudFront CDN to give users a better experience in those, you know, all over the world, because Spotify obviously is a global brand. They don't want to distribute it all from the US or from Sweden, where they're originally from. They leverage the benefits of CloudFront to deliver that client application. Okay, so for example, you could stick CloudFront in front of your our static website that we set up. I'll just quickly show you the CloudFront distribution console to show you how easy that is. Let's see if that's loading. No. So CloudFront, this is the content delivery network. I'll say create distribution. We have web or streaming distribution. We're going to get started with a web distribution. Origin name, we should find in here Jakarta Qatar S3. So that's where the actual stuff comes from. Origin path, it could be a subdirectory, but we're going to go with no origin path, so pointing straight into our bucket. The default behavior, so this is the cache settings of the content delivery network. We'll go with the defaults, but I just want to show you how easy it is to get started with CloudFront distribution. There we go. So there we go, there's one creating. I think it flashed up a message on the previous screen. So it takes about 15 minutes, so we won't look at CloudFront. But that's how easy it is to configure CloudFront in front of your website. Okay, great. So that's a common workload and one example of customers who are doing it. So you know, static websites is only one use case. Very common is for, you know, complex web and mobile sites and social apps. So as shown in the sample on this slide here, there's a sample architecture, and AWS provides this scalable web application environment and the scalable storage, which we've looked at more closely. Databases right on the right-hand side there, that's the RDS, which we talked about in the overview, so scalable relational database service. Content delivery, that's CloudFront, which we just set up. Cache, search, and other application services that make it easier to build and run apps and deliver a great customer experience. So we won't try and build a 3-tier application during a webinar, but if you look at this, starting from the left, Route 53, we looked at that. CloudFront, we looked at that. S3, we looked at that. Load balancer we didn't look at directly, but EC2 in the next tier, that's the instance that we set up earlier. Okay, there's 8 instances here, but you saw how fast it was to set up, and relational database services at the back. So, you know, you've seen how far we've come in just during the webinar, so you can see a 3-tier application isn't that much further ahead. Okay, moving on. Why AWS for backup? Let's go on to our next use case. So AWS gives you this reliable, durable backup storage without the upfront capital expenditure and complexity of tape libraries or NAS or filers and all those kind of things. It's pay as you go. And, you know what service I'm going to suggest that we talk about here for backup, and it's of course our good friend, our weekend birthday celebrator, Amazon S3. So it grows as you grow. Great for storing. It's essentially it's offsite. It's highly durable. We can do cross-region transfers. Lots of good reasons. Oh yeah, and secure. You can use encryption both to and from S3. You can use encryption at rest, we call it. So it's encrypted on the disk. You can encrypt it before you send it, or you can ask us to encrypt it, or you can use the key management server to encrypt it. So it's very secure. So and also for the security, all those options around security and key management server, and there's one other I didn't mention, hardware security module. This is for customers who must comply with regulatory standards such as PCI or HIPAA compliance. Amazon S3's data protection features can be used as part of an overall strategy to achieve your own compliance. So we make all those things available to you. So we'll get on exactly how you might use S3 in just a moment. But there's also this long-term retention in Amazon Glacier. So some types of data you need instant access to, like Spotify. There are 20,000 songs being uploaded every day and, of course, being listened to. But some stuff for compliance and regulatory compliance, you need to store it, but you probably don't need to access it that much. So data archiving, essentially. So first, companies choose to make expensive upfront payments for their archiving solution, and it doesn't always include the power, all the facilities and staffing and maintenance. Second, companies have to guess what their capacity requirements will be, and they over-provision and make sure they've got enough, and they don't want to run out of archive capability. So this set of circumstances results in underutilized capacity and wasted money. With Amazon Glacier, you only pay for what you use, just like S3. Amazon Glacier changes the game for data archiving and backup, as you pay nothing up front and pay a very low price for storage, and you can scale up your usage up and down as needed, while AWS handles all the operational heavy lifting required to do the data retention as well. Amazon Glacier is intended for cold archival. It offers incredibly low storage price and is intended for cold storage of data, for which recovery times measured in hours are appropriate. So it's worth noting, in a given month you can retrieve up to 5% of your data on deposit with Glacier at no additional charge. So Glacier, S3, Route 53, another service we're going to mention here. And this is easy ways to transfer data into AWS. This is for archive or backup or even for your website, it might be. So you can securely upload and download your data to Amazon S3 via SSL encrypted endpoints using HTTPS protocol. Some customers wish to entirely avoid the internet, and they will use AWS Direct Connect. That means they can have a private circuit directly into AWS. And of course, there's one other which we haven't spoken about yet today. It probably wasn't even on my slide. It's called AWS Import Export. So using basically your 2 terabyte portable disk drive. So AWS Import Export accelerates moving large amounts of data into and out of AWS using portable storage devices for transport. AWS transfers your data directly onto and off storage devices using Amazon's high-speed internal network, bypassing the internet entirely. So if you've got 20 terabytes that you want to store in S3 and then push back to Glacier, you can send us 20 terabytes of disk, and you don't have to upgrade your internet connection or get a direct connect. So that's another mechanism to get data in and out. Another interesting one is you can have an on-premise storage gateway. So it's a secure integration between your organization's on-premise IT environment and AWS's storage infrastructure. So that storage infrastructure I talked about was S3 and Glacier in this case. So the storage gateway, this service enables you to securely store data in AWS for all those benefits, scalable and cost-effectiveness that we talked about. And the AWS Storage Gateway supports industry-standard storage protocols that work with your existing applications and provide low-latency performance by maintaining frequent access data on-premise and encrypting the rest of the stuff and pushing it up to S3. But we'll look at those protocols. There are different storage gateways available in the marketplace, but the one we're going to look at the moment is the AWS Storage Gateway. It's an on-premise, and it presents basically iSCSI storage to your environment. It's $125 a month. You run this on your data center premises, and you want to do your backups, you literally send them to this iSCSI presented device from your storage gateway. They're encrypted as they're sent up to the AWS Cloud, and they're encrypted once they're written, server-side encryption into S3. You basically push all your data back. Now, there's 3 configurations which are worth noting. There's something called Gateway Cache Volumes, Gateway Stored Volumes, and Gateway Virtual Tape Library. I would just touch on what they are, because this one might be interesting if you've got a load of data on site, you want it off-site backed up. Cache volumes means that the primary storage is on S3, but you have a certain amount of cache locally, so frequently accessed files are pulled locally, but they're all synced back to S3. The next one, stored volumes, is the primary, the local, so you basically might have a big iSCSI filer, but in the background it's continually synced back to S3, so you've just basically taken care of backup, and it's offsite to S3. And the other one is virtual tape libraries. So if you already have a backup solution on site and you're backing up to like your small tape library and someone's got to change the tapes on Friday night or whatever happens, you can have a virtual tape library. So the Storage Gateway will present an iSCSI tape library to your backup software and essentially but push all the data back to Amazon S3. So it's a highly scalable, durable and reliable. Here's an example where you can have AWS in the middle, backing up multiple branch offices or your corporate data center, either over multiple storage appliances at each of those places. Okay, so once your data is then pushed up to S3 by your appliance, you may want to, for example, restore it back to on-premise. You've either just lost a bit of data or you've lost an entire server. And you can pull it back for immediate restore from S3 or 3 to 5 hour retrieval from Glacier if you needed to. And we did say we'd also talk about disaster recovery. So Storage Gateway offers you potentially, right, you have your on-site and you have all your equipment, and then you use Storage Gateway to push all your data up to S3. And S3, it stores as snapshots in S3. So should you have a disaster and it's not that you want to pull all the data back down, you can actually then create EBS volumes. That was the elastic block store. That's the other type of storage that you can present directly to Amazon EC2 instances. You can all your backups that have gone up to S3, you can create all these EBS volumes, and then you can stand up all your Amazon EC2 instances and have your disaster recovery site running in Amazon EC2. This is a pretty common use case because one of the advantages, obviously you only pay for the storage. You don't pay anything for the compute capacity that you're running in your disaster recovery environment because you're not running it. You only pay for it the moment you actually have a disaster and you stand up your environment and you build it into AWS Cloud. So this is a pretty compelling story compared to traditional disaster recovery scenarios. Okay, so with that, I'm gonna say we've looked at a bit of the DR, a bit of offsite backup, recovery to and from AWS. Earlier we looked at EC2, we looked at Route 53, we looked at S3. You saw how easy it was to get data in and out of S3. We did import-export. We may have looked at some other ones as well. And with that, I'll give you a few closing bits of information about this webinar. I hope you found it useful. I certainly enjoyed talking to you today. But it's a whole week of webinars, so if you found this useful, there's a whole set of stuff that you can go and look at on the AWS APAC Webinar Week website. And we've got a few special sessions as well. So on Friday, we have a solution for you to ask solution architects. So if you're interested in anything you heard today, whether it's a static site, a dynamic site, a storage gateway, DR, backup, whatever it is, you can join this webinar. We've got a whole load of solution architects who are going to be available to discuss your questions or any ideas that you might have. So that's a really good, fun webinar to be part of. It's quite interesting. And then also on Friday as well, it's a fun ending to the week. We're going to be, please ask your questions now. We've got people online to help answer them. And of course, we're going to have a whole round of questions, the best questions from the week and the most compelling ones that have all been asked the most often. We're going to have that on Friday as well. So almost there. There's one more thing you can do. If you think this might be interesting to you and the cloud is something that you want to find out more about or you want to experiment, there's online labs training that you can do. If you go to aws.amazon.com training, you'll find all of these. So they're called quick labs, and you can do the static website that we did. You can do that as a quick lab. And there's instructor-led classes, like there's a one-day essentials course, or there's architecting on AWS, a slightly longer course. They're available in your region. You'll find links to it from the training website, and the training takes place all over the region at different dates, so you can find the best classes for you there. And of course, there's certification, so you can validate your technical expertise, work hard, and gain certification to be an AWS certified SA or engineer. Okay, so with that, I will close. Thank you for attending. I hope you found it useful. There's a few minutes to ask some questions. I would say at the end of this webinar, you will, we have a survey, so we're only really able to gauge how the webinar is and engage, for example, my performance in doing this. on the feedback that you give us. So do stay at the end of the webinar, fill in the feedback form, and give us your feedback. Oops. And with that, thank you very much.